Okay, here we go. Chapter 7, Part 1, Definite Loops. And you've been playing with this a little bit already, so I'm just going to fly through this one. A counted loop, you know this from previous reading. It's another way to write repetitive code, and you repeat it a counted number of times, which is a concrete known number of times. So as you all have seen, you take the loop, you drag it in, and you can set the number yourself. So as we said, it's specified by count. That's just the name for the number. And let's try this out. So using a loop instruction, it saves time, it's convenient, makes it more elegant. It certainly does, and you can do things again and again and again. Okay, so this is a fun example. Let me show this one to you. Okay, if I play it, right, looks pretty cool. And you're going to see it's loop infinity number of times, which is if you wanted to do a specific count, you could just do it 5 times, right? You could watch it play, and it would run around 5 times. Probably should have picked 3. Sorry. Here, let me do a shorter one just so you can see. Isn't that cool? All right, whatever. You get the point. Okay, so let me just show you some of the animation in case you want to use this. All it's having is every time, and so it's a loop within a loop. You see this infinity times here, and here's 5 times here, and I was messing around and made this, but this should have been infinity. So really, it's just going to keep running, and you get the horse going up, the horse going down, etc., etc. So pretty cool animation. And as you saw, if infinity times is selected, it means it's going to run until the program is shut down. That's useful if you want a background thing. Remember we saw that with the Greek water scene. It's not useful if you need your program to end. So you need to be thinking about that and asking yourself that question. Okay, so you can also put a loop within a loop, and as you know, these would be called nested loops. So here's a pretty cool example. The whole Ferris wheel, meaning this entire thing, is going to rotate clockwise, which is that way. But the inner wheels themselves are going to run counterclockwise. And for every time that this thing goes around once, meaning like that, and coming back here, these inner wheels are going to go around twice. All right, so let's check that out. Okay, so watch this happen. You can see you got a loop inside a loop. I'm just going to play it. I might need to slow it down. Actually, that doesn't look too bad. Okay, so let's watch this. Keep an eye on it. Let's watch this point go around once right here. So you get a sense of the time. And then while that happens, watch this guy. I think I'm going to let you follow it with your finger rather than my arrow. But you can see that every inner circle goes around twice, while the outer circle goes around once. And the reason it stopped is this only looped 10 times. It's not that complicated. You do want to watch the time part of it to make sure that that's going to happen and match up. But other than that, it's pretty straightforward. Okay, so each time the outer loop runs once, the inner loop runs completely. So think about this, an outer loop that runs 2 times and an inner loop that runs 5 times will actually execute the inner loop how many times? Think about it, think about it. That's right, 10 times. All right, great news, because I know some of you just love functions, that you can use a loop count by calling a function as long as that function returns a number value. And if that function returns something that's not a whole number value, the loop instruction will automatically round that to the nearest whole number. All right, let me show you one last demo. Okay, so let me play it for you. He's going to turn face. All right, he walks towards her. I'm not sure why her arms are like that. But you can see that it's going to loop as many times as the distance between the guy and the girl. And the way that you run this is you just go to your functions, and guide distance to, so I would drag this in right here and put this here, and distance to what? And we said distance to the entire girl. That's all it is. All right, and if I move him around, so let's maybe put him back here, or maybe a little bit closer, let's see what happens. 1, 2, 3, and it worked. So that's kind of a useful thing, sort of like the alien robot. Wouldn't that have made life a little bit easier? And that's it. Go play with some loops and have fun.